So last week, on Friday, we talked about the mole. So just quick review of what the mole is. Okay, the mole is a unit of measurement. Okay, it represents a specific number of particles. Okay, it is the same for any material. If I have 1 mole of hydrogen gas, I have 6.02 times 10 to the 23 molecules of hydrogen gas. If I have 1 mole of salt, I have 6.02 times 10 to the 23 molecules of salt. Okay, always going to be the same number. Just like if I have a dozen of something, I always have 12 of it. It doesn't matter whether it's eggs or donuts or cars or whatever. Okay, a dozen always means 12. A mole always means 6.02 times 10 to the 23. We then started talking about the mole equation, okay, where N, which is the number of moles, equals little m, which is mass in grams, divided by molar mass in grams per mole. Okay, and we talked about how we calculate molar mass. That is, we look at the formula of the material and we add up the molar masses of each part, okay, to get the molar mass. And then N, like we said, is the number of moles. So in a question like this one, this is as easy as they come. Okay, this is the easiest type of mole equation problem. Okay, the question asks me how many moles. So they're asking me to calculate N. Then they go on to tell me they want to know how many moles of calcium chloride. Since I know the formula of the material I'm working with, I can calculate its molar mass, big M. Okay, since this stuff is calcium chloride, all I have to do is add all the parts together. So that'll be 40.08 because there's 1 calcium and there's 2 chlorines. So plus 35.45, that's the molar mass of calcium, and of chlorine, and there's 2 of them. So I multiply that by 2, right? Which tells me that the molar mass of calcium chloride is 110.98 grams per mole. That is, if I have 6.02 times 10 to the 23 molecules of calcium chloride, it'll have a mass of 110.98 grams. Okay. All right, the other thing they tell me is that I have 90 grams, so that's mass, of this substance. All right, so I have little m and I have big M, and I'm looking for N. Can I find it? Do I need to even manipulate the formula? No, it's already set up to solve for N. All I have to do is plug in my numbers. So I'll take my 90 grams and I'll divide that by 110.98. So I have just a little less than 1 mole here, agreed? Okay, 1 mole is 110, I have 90. So I have a little less than one mole. So I should get what kind of a number here? A decimal, yeah. All right, so let's figure out what that's going to be. So we got 90 divided by 110.98. All right, so I have 0.81 moles. How important is it to put units on? Extremely important. Without it, I don't know what that number means. Okay, so I have 0.81 moles. That question's done. I would say if I was being really generous, okay, that would be a 4-mark question. More than likely, it's a 3-mark question. You would get 1 mark for your givens. That is writing down what the question gave you, calculating the molar mass. That's 1 mark. Okay, you would get another mark for selecting the correct formula. Because you don't need to manipulate the formula in this one, there's no mark for manipulating. Okay, sometimes I give a mark for plugging the numbers in correctly, and then you would get a mark for your answer. Okay, so how important is it to show your work? Very important. Okay, if you don't show your work and you get the right answer, I will still give you full marks because you're either really good at it and know what to do, or you're an incredibly brilliant guesser, which would also deserve 4 marks because the odds of guessing the right answer are astronomical. However, if you don't show any work and you make a mistake on your calculator, how many marks will you get? 0. Okay, and I have seen this happen so many times. Kids argue with me about showing their work and the value of showing their work every year. Okay, and inevitably, if they don't, it comes back to bite them. Okay, I had a kid about 6 years ago now, refused to show any work. just wouldn't do it. No matter how much I tried to convince him it was important, he just would not do it. I don't need to show my work. Final exam, he forgets to put his calculator back into degree mode after it's reset. He gets more than half of the written response of his Physics 20 exam wrong and shows no work. As a result, instead of getting the 90 something he should have got, he got like 60 something. Okay? And this was a smart kid. Shouldn't have got a 60, but he didn't show his work and he made a silly mistake. Okay? That sucks. And that's why you show your work. Okay? Make sure you show your work. That way, a simple, honest, innocent mistake like, accidentally typing something in wrong only costs you 1 mark instead of 5. Okay? All right. Did everybody write that one down? All right. So here's the next one. So that's the easiest one. Okay? Here's the next one. So the next one will ask us, what's the mass of this many moles of a certain material? All right, so in this case, they're asking, what is the mass of 4.5 moles of magnesium bromide? And this is the way I would write the question. I would not give you the formula. I would give you the name in words, as I have there. Right? Because that also means I'm testing whether you can write the chemical formulas correctly or not. All right, so anytime we have a problem to solve in science, the first thing we do is we write down our givens. What is the mass? Okay, so we're looking for little m, because little m is mass. Of 4.5 moles, so what part of the equation is that? N. Okay, of magnesium bromide. All right, that's going to help me get my molar mass. So magnesium bromide, Mg is 2 plus. Bromine is 1 minus, so this is MgBr2. You'd be surprised how many people will forget to drop and swap that on a unit exam. And as a result, will not get many marks here because they won't have the right molar mass to start with. Okay, so that's going to mean 24.31 and 79.9, right? Okay, so there's our magnesium, 24.31 grams per mole plus 79.9, and there's 2 of them. Okay, so 79.9 times 2. All right, so we're looking at a molar mass here of 184.11 grams per mole. All right, so there, 1 mark. Okay, wrote down my givens and calculated my molar mass, 1 mark. So the formula I'm going to be using is the mole equation. Little n, or n equals little m over big M, and I'm looking for little m this time. So how do I isolate little m? All right, I multiply both sides by big M. I follow those 3 rules of algebra. Actually, we only need to follow 2 of them, okay, for this one, okay, in order to move big M over to the other side. Right now, I'm dividing by big M. So to move it, I do the opposite, okay? That's going to make it cancel here. And what I do to one side of the equation, I do to the other. Now I'm solving for M, little m, the mass. All right, so you would have got a mark for the formula. You would have got a mark here for manipulating it correctly. Right? Then we're going to plug in our numbers. 184.11, big M, times N, which we were told was 4.5. That's going to give me my mass in grams. So you'd probably get a mark for plugging in your numbers. Okay, maybe, maybe not. Sometimes I do, sometimes I don't. Okay, and then we just plug in our numbers, times 4.5. All right, so I'm going to have 828.5 grams of this stuff. Okay, 5th and final mark. Okay, questions on that one? All right, so that's 2 out of the 4 ways I can ask you a mole equation question. The last 2 ways involve using Avogadro's number. Okay, Avogadro's number is that 6.02 times 10 to the 23 thing. Okay, what does that number mean? That's the number of particles in a mole. Okay, it doesn't matter what I'm dealing with. Okay, it could be water, it could be calcium chloride, it could be hydrogen, it could be oxygen. That's the number of particles in a mole. Okay, so I'm going to have to use that number in the next 2 methods, and I'm going to show you how you do that, how you punch it into your calculator, all that kind of good stuff. All right, so write this one down. How many molecules are in 600 grams of silver nitrate? So now we're being asked to calculate the number of particles, in this case molecules, because it's a compound. Okay, so first thing we want to do is write down our givens again. Okay, we're looking for the number of molecules. By the way, I'm using that to represent number. I did not just write hashtag molecules. Okay, because that's just dumb. Okay, number of molecules, because that's what that used to mean. Okay, number of molecules is what we're looking for. Okay, we know the mass, 600 grams, and we know it's silver nitrate, so we can calculate the molar mass. So we got silver, which is a 1 plus, and nitrate, which is a 1 minus. So this is just going to be AgNO3. All right, there's our formula for silver nitrate. All right, so to calculate that, we got, silver's heavy. It's 107.87. Okay, so there's the silver, 107.87. We've got 1 nitrogen, so 14.01, and we have 3 oxygens. $169.88. All right, so that's the mass of 1 mole of that stuff. What can I find right now if I have little m and big M? N. That's probably my next step. Okay, I want to find N, the number of moles. Okay, so that's what I'm going to find next. So N equals little m over big M. So that'll be 600 grams, because that's what we were told the mass was, divided by big M, 169.88. All right, so I have 3.53 moles here. All right. I'm going to shift gears here for just a second. If I have 2 dozen donuts, how many donuts do I have? 24. How'd you do that? I have 2 dozen. Yes, you could be a smart aleck and say 2 dozen. If I have 2 dozen donuts, I actually have 24 donuts. How'd you do that? How'd you figure that out? Right, you took the number of dozen, 2, and you multiplied it by how many donuts are in a dozen? 12. 2 times 12 is 24. You did that without thinking. Okay, the same should be true for this step. This is how many moles I have. This is how many of anything there is in 1 mole. So this is like 12, and this is like 2. Okay, Works exactly the same. This is how many particles are in a mole, just like 12 is how many is in a dozen, and this is how many moles I have. Okay, so what I'm going to do with these two numbers is multiply them. Okay, if I have 3.53 moles and I multiply by the amount in a mole, I'll have the number of molecules. Okay, so that is my next step. Okay, so we take the number of moles, we multiply by Avogadro's number. Okay, so that'll be 3.53 times 6.02 times 10 to the 23. All right, now you're probably going, holy crap, how do I put that in my calculator? Well, it actually depends what kind of calculator you have. But in general, okay, you are going to use the exponent function here. So here's how on a TI-83, if you have one of those, or TI-85 or TI-900, whatever we're on now, okay, here's how you do it. So we'll take our 3.53, and then we're going to multiply by Avogadro's number. Avogadro's number needs to be enclosed in brackets. Okay, so I'm going to put brackets, and then I'm going to go 6.02. That's the easy part. Okay, now I need to tell it that there's a power here, a power of 10 that this is going to be multiplied by. So I hit the second function button. So I get the arrow, and then I'm going to hit the comma. You can see above the comma, you've got two capital E's. Okay, two capital E's is what you see on a lot of calculators. If you don't see two capital E's, you might see capital EXP. It does the same thing. Okay, so it kind of depends on what's on your calculator, right? But if you have, so you're going to hit second function and the comma, and when you do that, it gives you this E here. That E means times 10 to the power of. Then you put in the power. Okay, this is to the power of 23, right? So that means 6.02 times 10 to the power of 23. All right, don't put in times 10 and then hit E. That'll put in an extra power of 10. It'll be 10 to the 24. We don't want that. Okay, just the E with a 23 after, and enclose the brackets. All right. Now, if your calculator doesn't have that, or you're using your phone for a calculator, I think the iPhone has the EE. Okay, so you just got to find, you've got to turn it on its side so you get the scientific layout, okay, and you'll be able to find it there. Same thing, and close it in brackets EE. If you got something else, I can come around and have a look. Okay, everybody okay with that? All right, so when I multiply this, there's my number of molecules. So 2.13 times 10 to the 24 molecules. Is that a lot? It is a lot. Okay. Okay, and I need to put molecules after that. Molecules is my units. Okay. All right, so a question like this, okay, in terms of marks, you get a mark, again, as always, for your givens. Okay, you would get a mark for this step, right, possibly for plugging in your numbers correctly. Then you would get a mark for this step and a mark for your answer. So it would be a 5-mark question. All right, what if a question gave me the number of molecules and wanted me to calculate the mass, the opposite of what I just did here? Right. If I want to get the number of moles, I would take the number of molecules and divide it by Avogadro's number. Okay, the opposite of what I just did here. Okay, it would be the same as if I said you have 36 donuts. How many dozen do you have? 3. You went 36 divided by 12, and you got 3. Okay, so same idea. All right, so spoiler alert. That's the last way I can ask you a mole equation question. I give you the number of particles and ask you to calculate its mass. All right, so I'll give you a minute to get that one written down, and then we'll walk through it. So in this one, my givens are the number of molecules. And that is 1.54 times 10 to the 25. Okay, And I'm told it's diphosphorus tetraiodide, so that's P2I4, right? Which will help me, of course, to calculate my molar mass. Okay, so I've got phosphorus, which is 30.97, and I've got iodine, which is 126.9. Right, so 32.07. And there's two of them, and there's 4 iodines. Okay, so it's a relatively heavy material. All right, so 571.74 grams per mole. Okay, is my molar mass. Okay, if I'm going to calculate mass, that's little m, I need the number of moles and I need molar mass. I have molar mass already. I need to calculate the number of moles. I can do that because I know the number of molecules I have, and I know that in 1 mole, there are this many. Just like a minute ago when I asked you how many dozen are there in 36, and you went 36 divided by 12 and told me it's 3. Okay, so I'm going to take this number here and do what with it? I'm going to divide it by this. This is the 36 donuts. This is the 12. Okay, this is the number in a dozen. So if I take the number of molecules I have and I divide it by the number of molecules in a mole, I'll be left with the number of moles. Okay, so that's my next step. N will equal, okay, 1.54 times 10 to the 25 divided by Avogadro's number. Okay, do I have a lot of moles here? Yes. All right, so both of those numbers will need to be enclosed in brackets now because they both have those exponents on them. So I'll go bracket and I'll go 1.54 and then I'll put the E in there, 25, and then I'll divide by Avogadro's number, which is also enclosed in its own set of brackets. 6.02, second function, okay, hit the E button, 23, and close the brackets. I have 25.58 moles of this stuff. Okay. Okay, so now I know N and I know big M. Can I solve for mass? All right, but then I have to manipulate this equation, which means I got to multiply both sides by big M. Okay, so I will have then that the mass equals 25.58, that's N, multiplied by my 571.74, okay, which was my molar mass. So there's quite a bit of this stuff, like a load of it. All right, so I've got like 14.5 kilograms of this stuff. It's like 30 pounds, okay, of this stuff. Okay, so I would write down 14,625.91. 25.91 grams. Okay, that would be my mass. All right, so this would definitely be worth 5 marks. Okay, because there's a fair amount of steps here. Okay, so let's back up and look at where the marks would be here. So we'd have a mark for our givens. here, okay? We would have a mark for this step, because that's what we did next, calculate the number of moles, okay? We would have a mark for the manipulation here, okay, of the formula. We would have a mark here for plugging in the numbers. Fifth mark is our final answer. Okay. All right. There are only those 4 ways that I can ask you a mole equation question. Right? Each day this week, I will go over a different 4 questions, but it's always the same 4 methods. Okay. All right. Let's have a look at just some more simple ones here. Okay, so for question number 1, there's actually not a lot of calculating here. It's just asking me some kind of basic questions about my understanding of the mole. All right. If I have 1 mole of gold atoms, how many atoms do I have? Well, no, you're looking at the wrong number too. That's the molar mass. How many of anything is there in 1 mole? 6.02 times 10 to the 23. Okay, this is just to reiterate the importance of Avogadro's number. It doesn't matter what this material is. It could be phosphorus. It could be, like whatever. It could be any element, and the number. It could be a compound even. If it's number of molecules, it's 6.02 times 10 to the 23. That's how many of anything there is in a mole. Okay, if it's asking about 1 mole, that's the number. Okay, what if I have 2.5 moles of helium atoms? How many is that? 2.5 times this number. It's always this number. When we're dealing with moles, it's always that number. Okay, that's how many there are in a mole. So if I want to do question number 2, okay, or sorry, question number 1b, then I take 6.02 times 10 to the 23, and I multiply it by the number of moles. They said 2.5, so I put in 2.5. I've got 1.505 times 10 to the 24. Oh, 10 to the 24. Okay, and that would be atoms. Okay, what about for C? How many hydrogen molecules in 10 moles? Right, 10 times Avogadro's number. Okay, if Avogadro's number is 10 to the 23, and I multiply that by another factor of 10, it's going to be 10 to the 24. Okay, just move the decimal, right? Every time, what are we doing? Multiplying n by the number, by Avogadro's number. Okay, we're always taking the number of moles and multiplying by Avogadro's number. Anytime a question asks how many atoms or molecules, we multiply by Avogadro's number. Okay, we multiply n, I should be more specific, multiply n, okay, by Avogadro's number. All right. Question number 2 is going to ask you to use the mole equation to calculate something. Okay, it's asking you to calculate the number of moles, which is what part of that equation? N. Okay, so number 2, all of the questions in number 2, A through E, are asking you to calculate N for a different material and a different mass. Okay, so they all give you M, little m. You'll have to calculate or look up what big M is and perform those calculations. Okay, I'm going to post the key on Google Classroom right now so you can check your work as you go. Okay, but I want you to work on question number 2 right now. All right, so for question A, we want to find the number of moles, so that's N, of 28 grams of sodium. So they told us what M is. So basically we just have to plug in our numbers. We have 28 grams, okay, and we divide that by the molar mass of sodium, which is 22.99. grams per mole. Right, so we get 1.22 moles, okay, is what we're looking at there. All right, everybody okay with that one? Right, if we're looking at B, okay, it's going to be a similar thing here. We have 28 grams, but this time it's of iron, right? So N is going to equal our mass divided by our molar mass, 28 grams, this time divided by 55.85, right? Grams per mole, that's the molar mass of iron. Okay, so this time I have less than a mole, so I have 28 divided by 55.85. Right, 0.50 is our number there. Right, we always want to put units on our answers. On each one of these, we're calculating the number of moles, so we put MOL because we're very busy. We don't want to write the whole word, right? So the abbreviation is MOL. You laugh, guys. We are a society that has an abbreviation for the word at because we're just too busy to write the whole word. I don't know what to tell you, but it's true. Okay, we have abbreviations for everything. All right, keep going on that, and if you get done that one, then try number 3. Number 3 is just asking you same formula, but now calculate little m, okay, for each one.